10 or 11? Which one would you rather work? 11? Okay. So we want to rewrite it as 3x cubed minus 1 to the what power? 2/5. Good. All right, so h prime is going to be what? 2/5. Good. That parenthesis, when you bring the exponent down from the top of the parenthesis, what's inside the parenthesis never changes. What's the new exponent? Negative 3/5. And then you have to take the derivative of what's inside the parentheses, so 9x squared. And you're done. Okay, number 12, the secant of 3x. Here, we were pretty much using the power rule. The big thing that we need to take the derivative of is the secant on number 12. So what's the derivative of secant? Secant x tan x. But if I take the derivative of secant 3x, I've got to keep the same argument. So it's the secant of 3x times the tan of 3x. And then I need to multiply by the derivative of what's inside that parenthesis, which is 3. So it's still kind of like the power rule. It's just that the outer part is the secant, and so you need to take the derivative of secant, keep the same argument, just like when we rewrote the parentheses up here. We kept the same thing in the parentheses, and then you take the derivative of the parentheses. I like to think about it as peeling an onion. An onion has a whole bunch of layers on it, and when you peel an onion, you have to peel off the top layer, and then you can continue to peel off any other layer. So we're starting on the very outside of that onion and taking the derivative and going inward. So the derivative of secant is secant tan. Keep the same argument, and then times the derivative of that parenthesis. Because think of it as, okay, think of it, we're going to let u equal 3x. Yeah. So h is now the secant of u. So the derivative of secant u is secant u tan u. And then I have to take the derivative of u. Yes, so your secant is like the n, or what you're, yeah, okay, hold on, let me go back and modify this right here. Right. This is kind of a power rule representation, but when we take the derivative of sine or cosine or secant or anything like that, it's not really a power rule. So the derivative of, say, the sine of u, the derivative of sine is cosine, and then I have to multiply by the derivative of that argument. Give the trig functions a couple more chances, and then I think you'll feel more comfortable with it. All right, now the only thing about the trig functions is that they can get kind of confusing, especially when parentheses are involved or understood to be there. If you have things multiplied together after a trig function, it's understood that that entire thing is the argument. So the cosine of 3x squared, it's understood that there are parentheses around the 3x squared. So to take the derivative of cosine is negative sine, but you keep the same argument that you started with, so 3x squared, funky 2, and then times the derivative of that parenthesis, which is 6x. And you're done. So peel that onion. You're taking the derivative of cosine, keeping the same parenthesis, and then times the derivative of that parenthesis. All right, B. This one's kind of a trick question, and it's so easy that it's kind of hard. What can you tell me about the cosine of 3? It's a constant. It's just a number. And this is a number times x squared. if y equaled 5x squared, what would the derivative be? 10x, or 5 times 2x. So what do you think the derivative of the cosine of 3 times x squared is? Yep, 2 cosine 3 times x. However, it's a pretty good idea to, if you don't put a parenthesis or a time sign between the 3 and the x, reading that is going to look like the cosine of 3x, not the cosine of 3 times x. Okay, the cosine of 3x, the quantity squared. Does that mean the cosine of 3x times the cosine of 3x, or does that mean the cosine of 3x times 3x? The second one. So it's really the same thing as the cosine of 9x squared. You okay with that? All right, so peeling the onion and taking the derivative of cosine is negative sine. What do I use for the argument? 9x squared times 18x. Good, the derivative of that parenthesis. Because if you, the squared right here is only attached to that 3x. So 3x times 3x is 9x squared. Now look at how similar C and D are. Because if I really wanted to, I could even put parentheses around that 3x on D. And the difference is where that parenthesis is. You're used to seeing, when we square a trig function, you're used to seeing that squared sign right up against the cosine. But what it really means is the cosine of 3x, the whole quantity squared. You could use the product rule, or we could use the chain rule kind of as a power, like going back to the big chunk of something to a power. So like when we did something like 3x minus 5 to the 4th power. Okay, let's just refresh our memory on that. Using the chain rule, that would be 4 times 3x minus 5 to what power? 3rd times what? 3. Just 3, because the derivative of 3x minus 5 is just 3. Okay, so we did the power rule. All right, so let's use the power rule here. So the 2 is going to come down in front. The parenthesis does not change. My new exponent is 1. Okay, so we started on the very outside with the power rule. So that's the first layer of the onion. Okay, the next layer of the onion is the cosine. What's the derivative of cosine? Good, negative sign, but I have to keep the 3x. And then times 3. Okay, so let me talk you through this again. We're peeling the onion. The very outside is the exponent. So the exponent came down in front, rewrite the parenthesis to the first power, and now I have to take the derivative of what's inside the parenthesis. So the derivative of cosine 3x, I start with the derivative of cosine, keep the same argument, and then I still have to take the derivative of the 3x, which is 3. It's basically, we had 3 layers of this onion. We had the power, the trig argument, or the trig function, and then the argument. Okay, this is good. PTA. Your parents are all members of the PTA. Power, trig function, argument. So we took the derivative of the power, then we took which was the 2 cosine 3x to the first, then we took the derivative of the trig function, which was negative sign, then we took the derivative of the original argument, which was 3. I would rewrite it like this first. Okay, so PTA, power, 3 comes down in front, parentheses squared. Then trig function, the derivative of cosine is negative sign. 5x, and then the argument derivative of 5x is 5. Most of them are not as hard as D and E.